All right, so the first one, Coffee County School is having a food drive to help with the victims of Hurricane Helene. After one day of collecting, the school collected 1.2 tons of food. After 4 days, the school collected 3.5 tons, and after 7 days, the school collected 8.1 tons of food. The amount of food collected can be modeled by a function given by f of t, and I did make a mistake on this, and it will be on every single one of these examples. These should all be t's, not x's. Where f of t is the total weight of food collected in tons t days after the food drive began. All right. So on this one, what I would do is I would go over to the side and just write down 3 ordered pairs that you were told in the words of the problem, where the first one, the input, is going to be the day, which would be day 1, and then the output will be the amount of food that had been collected up to that day. So that's going to be 1.2. And then day 4, the school had collected 3.5. And then 7, 8.1. You do not get points for that, but it's going to make it easier to do our regression equation when you have it kind of organized instead of just all over the place. And it'll help make it easier for you to do part A. All right. So we are going to learn tons of regression. So we're going to learn exponential and logarithmic, and this one is quadratic. That might be all it is, all the possibilities for this question. That's all I can think of off the top of my head. But part AI and II will be the same. The only difference, this might say 2 instead of 3, and it might just be A and B, but the wording will be exactly the same. So the first part, we are going to use the data to write 3 equations that can be used to find the values of the constants A, B, and C. And so we are going to take these ordered pairs and we're going to plug them in for f of t and for t. And so f of t is going to be the output. So our first equation is going to be 1.2 equals, and then A is A, it has to be there. T needs to be that input value that we used for that ordered pair. So that's one equation. The second equation, we're going to do the same thing. We are just start with the output. And then put in our input for t. And then one more time. And there is absolutely no reason for you to square 7 and square 4 and change those. That's some mistakes that people would make, would be just making a mistake like that they didn't even have to do. You also need to make sure that you remember those squares. So that's probably the biggest careless mistake I saw on this question, is they would just forget. Or they would put the square on the A instead of on the 2. So just be careful. That is really an easy point to get right. A really easy point to earn right there. The second one is also pretty easy to earn as long as you know how to do regression equations. And so 2 says to find the values of A, B, and C as a decimal approximation. So we're going to put the data in the calculator. I'm going to let you guys do this without me helping you. I think you're fairly certain you've got this. So you're going to go to Stat and Edit, and then your list 1 is going to be the 147, and list 2 are going to be those 3 output values. Yes. A equals B equals C equals. What type of regression equation do you think we should do? Yes, quadratic. That wasn't a trick question. So because this model is quadratic, you're going to do a quadratic regression. And then, like he was asking, all you have to do on this one is be accurate to 3 decimal points. Just put A equals, and I'm putting all possible answers here that are correct to 3 decimal places. You only have to do one. But I just wanted you to see the possibilities. That's all they're looking for. That's what A equals, what B equals, what C equals, accurate to 3 decimal places. If you mess up on one of those decimal places, you get none of those points. Because it's just a 1-point question. I don't know why I wrote of instead of or. That's okay. I'm a little off today. I don't know what's wrong with me. All right, you guys good on A, B, and C? Sweet. Okay, then this next part, I'm hoping you remember from when we did this before. So we are going to use the given data to find the average rate of change in the amount of food collected in tons per day from T equals 1 to T equals 7. We're going to express our answers as decimal approximation, and we are going to show the computations that lead to the answer. So this is just the average rate of change formula. Now it's super important that you do what it says, and it says to use the data. It does not say to use the regression equation. If you use the regression equation, there's a good chance you're going to miss it. So we're going to use the data. You do not use this point right here because we're just doing 1 to 7. So in the numerator, you're going to subtract 81 minus 1.2. Not 81, 8.1 minus 1.2. And the denominator, you're going to do 7 minus 1. Subtract the outputs on the numerator, the inputs in the denominator. So you guys go ahead and do that. Now, it is important that you don't give your answer as a fraction. It is important that you give your answer as a decimal. So the correct answer would be 1.15 tons per day. Now, it is all right if you leave off the units. I will always write them just because they're so important in calculus. I'm just in the habit. I will always write them. But if you just wrote this much, it's fine. But you have to have your work shown. You can't just write the answer. I know you can do it in the calculator, but you cannot just write that. It will be wrong. Or it just won't be enough to earn your point. Okay, and then part 2, we want to use the average rate of change that we just found to estimate the amount of food collected in tons on day 9. And again, we have to show the work that leads to our answer. So, do you guys remember writing the equation of a secant line? Do you remember hearing secant line, those words? Okay. So we wrote the equation of a secant line. It is going to be this. I'm going to try to remember to use T on this. If you mess up and write an X like I have been doing this morning, it's okay. But I'm going to try to practice it perfectly. So it is super important, again, that we do not use the point that wasn't used when we found our average rate of change. If you try to use the point for 3.5, it will be 100% wrong. And so you guys get to decide, do you want to use the one with 1 or the one with 7? Doesn't matter. Say it again? 1? Okay. And so what we would do, the y1 is going to be that 1.2. The m is going to be our average rate of change. I'm going to write t, and then from it, I'm going to subtract the 1. All right, and so to answer this question, I need to put 9 in for t. All right, so once you get that plugged in, or once you get that written, you can just type that in the calculator, and it's 1.4 tons. Now, I saw people do other things, and they got their points also. So what I saw a lot of people do is they would say, okay, so at 7, it's 8.1. So then they would do something like 8.1 plus 2 more slopes and give that as the answer, and that's perfect also. That is what we did too. But you have to show it. Anything you do, you have to show it. Or some people would do the 8.1 and then they would add a slope and then they would add another slope, and that's fine as long as you're showing it. But just the answer is not okay. Okay, and then we did ones like this next one a lot. We practiced it a lot, but it's been a little while, so you may or may not remember it. But we are going to let A sub t represent the estimate of the amount of food in tons using the average rate of change found in part 1. For A sub 9 found in part 2, it can be shown that that would be less than if we just plugged 9 into our regression equation. We plugged 9 into this. We want to explain why, in general, A sub t would be less than f of t for all of t where t is greater than 7. So again, it's a ton of words. But on this question, there's 2 things you're going to have to talk about. You're going to have to talk about if the f is concave up or concave down. Important, you have to talk about that. And you're going to need to mention the secant line. Okay? And so for this function where A determines if the graph opens up or down. Where A is a positive value, would this be concave up or concave down? Parabola. Up. So what I would do is I would draw at least a partial parabola that's concave up. You can draw the whole thing, it's fine, it doesn't matter. And then I would draw a secant line through it. I would label the parabola, parabola is F, the secant line is A. Okay. It's also extremely helpful if you label the points that the secant line goes through. So that's going to be this 1 and the 7. Alright, so if we're going to explain it, I would start off by talking about A of t is the secant line, or A sub t. So it's the secant line of f of t passing through t equals 1 and t equals 7. Now you've also told me that on the graph, and so sometimes you can get that point without saying the actual words, but I want you to do both just to make sure we get that point. Alright, and then you're going to have to talk about if f is concave up or down, and we already said f is concave up, so because f of t is concave up, the secant line will fall Alright, now we're talking about t's that are greater than 7. So on this side is 7. So yeah, it's less than. So the secant line is always gonna fall below. And we would know that because it tells us it's less than for both of those. So the secant line will fall below f of t when t is greater than 7. Now again, you can probably get away with a little bit less, but I know 100% if you write all that and draw that picture, you're good, you're golden. All right, any questions on that? Okay, and then part C is going to be something usually that's talking about some real life restrictions on the domain or range or something like that. So for this one, a tractor trailer truck or the tractor trailer truck used to haul the food only has the capacity for 30 tons. Explain how this limits the values of t that are reasonable for the function f of t. And so you can like find what the domain would be, like where it gets up to 30 tons if you want to, but you do not have to. You just have to explain how this would limit the values of t. So what is the smallest value of t that there could be? 0. So t will be limited to t equals 0 to the t value that gives an output of 30 tons of food. So you don't have to find it. They're not asking you to find it. They're asking you to explain how that's going to limit it. Now, some people, when I was grading this question, thought they saw limits and thought they had to do a limit. That's not what it's asking for. It's asking for you to make a logical decision. Okay, we're going to do one more, and hopefully you'll have a little time to work because a lot of you don't have calculators. But I feel like a lot of you have that app on your phone that helps you. I think it does a good majority of what you need. So, and you could use Desmos, or you could, I guess it's Calculate 8v4 or something like that. I don't know, whatever. I feel like you guys are good. And if you really, really need to, you can borrow a calculator from me. I have a, like 200 in the closet. All right, so for example 2, I don't know if you guys know this because it happened way before you were born, but just after midnight on March 24th, 1989, the oil tanker Exxon Valdez ran aground on the coast of Alaska, puncturing the hull and spilling oil into the sea for 5 hours. The table gives the amount of oil spilled at selected times in T hours since the accident. The amount of oil can be modeled by the function g, and these need to all be t's again, where g is the amount of oil spilled in millions of gallons t hours after the accident. Okay, and so a lot of times for the quadratic, they give you a table, which is great. So the first thing you all would do is, we're going to write our 3 equations. So we'll start off with the output equals, and then we're going to put our input values in for t. Alright, then you need to put the data in the calculator. So go to Stat Edit. Hey Hunter, are you writing G of 0 and G? That's wrong. That is a common thing that I saw people do. That is, you will not get the point if you do G of 0 or G of 5.8. It's just 0 equals 5.8 equals and 10.8. So be accurate to 3 decimal points on your A, B, and C, except C is just 0. We don't have to have decimal points on it. All right, and then for B1, we're going to do that average rate of change. It's super important that you use the correct ordered pair. So from now on, we're going to pretend like this point 0, 0 doesn't exist. We cannot use it anymore. We're only using these 2 points. And so we'll subtract the outputs in the numerator and the inputs in the denominator. You do the quadratic regressions in the calculator. Yeah. All right, now part 2 here, sometimes it's not this exact thing. Sometimes it will say, explain the meaning of the average rate of change in the context of the problem. And we will practice that, I promise. But right now, I really want you to get the secant line thing down. And we'll do this with exponential and logarithmic, and you'll have plenty of time to practice all the things, don't worry. All right, so we are going to use that average rate of change to predict the amount of oil spilled at t equals 2. And so we're going to write our secant line using either point that is not 0, 0. So which one would you rather do? 3.25 or 5? Okay. So it's going to be y equals, and the output for 5 is 10.8 plus our average rate of change times t minus 5, that input value that we decided to use. All right, and then we want to find y of 2. All right, any questions so far? All right, and again, you can logic your way to that also, as long as you're showing your work, showing what you're doing. And you'll have a ton of space. Like this is squeezed pretty small because I was trying to use less paper, but you'll have a ton of space to write anything you want to here. All right, and then number 3, we want to, this is worded a little differently. This is worded to me a little bit more difficult to articulate the answer, but we're going to consider the values that result from using the average rate of change found in 1 to estimate the amount of oil spilled for times t equals p hours when p is between 3.25 and 5. Are these estimates less than or greater than the amount of oil spilled predicted by the model G at time t equals p hours? And it will say explain your answer. I didn't type it here, but you'll have to. Okay, so is this one going to be concave up or down? Up again. So we can draw a parabola, or at least a partial parabola. We're going to draw our secant line. We are going to label the parabola G, and the points on our secant line are 3.25, whoops, and 5. And I'm going to quote the problem a lot on this one because it's easy to just say something a little bit wrong, but if you're quoting the problem, you're probably good. So I'm going to start right here, and I'm going to write almost exactly what this is, but I have to decide between less or greater. So if we're talking about between 3.25 and 5, are the estimates from the average rate of change going to be less than or greater than? Greater than. So I'm going to say these estimates are greater than. And I'm just going to quote the problem. So I'm starting right here with the amount of oil, blah, blah, blah. Alright, so I am going to go back after t equals p hours and tell that p is between these two. Alright, but we do have to explain our reasoning. Alright, because what do we know about G? It is quadratic and it's concave up. We need to talk about concavity on this problem. And the secant line will fall. Oh, I forgot something that's also important. It's going to be the secant line through t equals 3.25 and t equals 5 will fall above G when 3.25 is less than t is less than 5. Or you could say t is between 3.25 and 5. There's lots of ways you can word that. I know it feels kind of repetitive, but we want to get everything in there. Okay, and then on C, given the context of the Exxon Valdez oil spill, what is the domain and range of G, and explain your reasoning. Okay, what is the smallest amount of time we could have this oil spill for? And what is the largest amount of time for this particular oil spill? 5, good. And your reasoning would be something like oil spilled for 5 hours. All right, what about the range? What do you guys think?
It should be 0 to 10.8.
Absolutely. And the reasoning is something like at the end of the spill, $10.8 million gallons. I think they told me today it should be, the correct grammar would be had been spilled. If you use incorrect grammar, it is okay. Grammar is not graded at all on these. Neither is handwriting. All right, what questions do you guys have?